All right. So we're going to begin with question 1. This is from section 7.3, guys. Suppose a production line operates with the mean filling weight of 16 ounces per container. Don't write the claim before you read the entire problem. Since over or under filling can be dangerous, a quality control inspector samples of 24 items to determine whether the filling weight must be adjusted. So this is a question 1. And N is 24, as you can see, guys. The sample revealed a mean of 16.32 ounces. So X bar. No 1 and 2 here. It's chapter 7. Just one sample, guys. With the sample standard deviation. So that's S, guys. You don't work with sigma here. It's S. He says sample. Using a 0.10 level of significance. So alpha is 0.10. Can it be concluded that the process is out of control? And I gave you a hint here. It says not equal to 16 ounces. So we need to check that the mean is not equal to 16 ounces. We start like this, HO, HA. If you want to put the unit, that's fine. If you're not, all right. So mean is not equal to 16 ounces. This is our claim. And I think, guys, it is obvious that this is going to be a t-test. It meets the t-test requirements, t-distribution requirements. So we're going to run a t-test. And I'm going to get my calculator. And if the reason, again, you ask me why a t-test, he didn't give you the population standard deviation, guys. He gave you S. So let's do this. And guys, do it together. I'm going to go slow, so I'll give you a chance also to do this problem as well with me. So you go to stat, tests, t-test, and now let's do what we have. I don't have data. I have a summary, which is stats. Mu0, it's the value and the null hypothesis, which is 16. X bar is 16.32. Standard deviation is 0.8. N is 24. And mu is not equal to mu0. And I'm going to hit calculate, guys. And I got T to be 1.9595. So if you round it, guys, it's going to become 1.96. And the p-value is 0.0623. So here's a screen. Let me write them down. T is 1.960. And p-value is 0.0623. All right, and now, I noticed that some students had hard time distinguishing whether this is less than or greater than. Well, guys, this is how you compare with alpha. I'll show you again. Look, this is how I would compare if I were you. The 0 is the same as the 0. So they are equal as of now. We have a dot here. We have a dot here. We have a 0 here. And we have a 1 there. Well, we know 0 is less than 1, so that must be less. It could have been that some students confused the sign. They thought that this is a greater than, and then they put the other sign, because I noticed that some students had hard time with distinguishing the signs. So, but that's very important, guys. Or change this to a percent, 6%, 10%. Well, 6% is less than 10%, so we reject HO. And then, guys, we say there is enough evidence at the 0.10 level of significance to support the claim that the process is out of control and needs to be adjusted. Out of control means it's not exactly 16, and it needs to be adjusted. Any questions, guys? So this is a t-test. It's very important, guys. The t-test is extremely important. Just like a 2-sample t-test, this one sample t-test. All right, so that's this is question 1. So that's done. Question 2, we're gonna do question 2 now, guys. Let's read the question 2. A survey done 1 year ago showed that 45% of the population participated in recycling programs. In a recent poll, a random sample of 1250, that's N, guys, showed that 598 participate in the recycling program, that's X. Test the hypothesis that the proportion of the population who participate in recycling program is greater than what it was a year ago. Can someone tell me what was the proportion a year ago, what we're testing against? So what was it a year ago, guys? Yes, 45%, exactly. Yep. And the recording will be available today, yes, definitely. Okay, so use 5% significance level. Okay, let me just write down what we have, guys, and then I'll move the page. So we have N is 1250, X is 598, alpha is 5%, and he's asking us to check that it is greater than what was a year ago. There you go. PP, greater means more than 45%, do it 0.45, and that's the claim. And that's 0.45 right here. And what's the name of the test that I'm gonna be using right here, guys? Can you remind me? Not a z-test. This is a P. So it's called what? One proportion z-test. Okay? Yep. All right, let's do it. I got everything I need to perform the test. So just turn the calculator on. I'll hit clear, stat, tests, one prop z-test number 5. Okay, first of all, we want the value in the null hypothesis, which is 0.45. Remember, we assume always a null hypothesis until proven otherwise. Remember, defendant is not guilty until proven otherwise. So it's the same concept. X is 598. N is 1250. And we're testing that P is greater than P0. And watch, guys, calculate. You can do a draw as well. So Z, 2 decimal places. Write it down before I write it down. So it's gonna be 2.02. And P value is 0.0218 for 4 decimal places. All right. This is alpha, guys. What do I put, less than or greater than? Yep, I agree. It is less than, so we reject HO. Unlike the session last time, mostly was failed to reject HO. Today is rejecting HO. So we reject HO and we say there is enough evidence at the 0.05 level of significance to support the claim. And what is the claim here? Let's go back and read the claim together. The claim that the proportion of population who participate in recycling is greater than what it was a year ago. The proportion of participants in recycling program is greater than 45%. Any questions, guys, about question number 2? So that's the question number 2. Let's do the next one. Okay, we did 8.2. We did this. We did that, question 4. I will send you a PDF with the answers as well. I think we did 5, right, guys, as well? That was number 5. Yeah, we did that. So let's go to next page. Did we do number 6, guys? Probably we did. 3, 4. 5. Yeah, we did number 6. 7. We're gonna do number 7 right now. Yeah. Okay. Number 7 we haven't done yet, so let's do number 7. I'll do it on a separate sheet of paper. Okay. An overnight package delivery service has a promotional discount rate in effect this week only. For several weeks, the mean weight of a package delivered by this company has been 10.7 ounces. So they're saying it has been 10.7 ounces. I don't want you guys to go and write the null and the alternative. You have to wait until to see what the question is, because he might change the question later and tell you test that it is different from 10.7. So read the whole thing and then answer the question. And this is what happened on the assignment for question 1. They started with saying that the mean prison time is 13 months. And I think almost every single student put the claim in the null. But then later he asks you, can you check if the mean is different from 13 months? And that should have been the claim. The claim is what the questions is in the problem, the one who's asking you the question. So please pay attention to this. So they say for several years, the mean weight has been 10.7. A random sample of 12 packages mailed this week has a sample, so that's N, has a mean weight of 11.81, that's X bar, with a standard deviation of 2.24, that's S. Test the claim. See, now the question, that the mean weight of all packages mailed this week is greater than 10.7 ounces. So I hope that you guys got the message what I'm trying to tell you. Wait until you read the question. Use 1% level of significance. So let's write them down. Question 7, guys. So I got X bar is 11.81 ounces. I got S to be 2.24 ounces. And I got N to be 12. We assume all population are normally distributed, guys. But from the beginning, I said that alpha is 1%. And test the claim that the mean is greater than 10.7. So we're not testing the equal here. It says greater. So it's going to be like this, guys. Mean is greater than 10.7 ounces. And here, the opposite, less than 10.7 ounces. And this is your claim. And we'll do this together. Yes, the claim is what the question is again. I know for the assignment, many of you started reading, it says equal and they use equal, but he didn't ask for that. He asked for something else, and it's the same in question 7. So 10.7 ounces here. And you guys agree with me that this is a t-test? So let's run the t-test, and that should be it. Stat tests, t-test. mu0, we're testing against 10.7. X bar, guys, is 11.81. S is 2.24. N is 12. And we're testing mean greater than mu0. Okay, I'm gonna do a draw here, guys, just to show you the p-value in action. It's a right tail test, so if anything shaded, it will be on the right. Okay, T, I can read 1.7166, and the p-value is 0.057. Okay, I'll write them down. So that will be 717. And p-value is 0.057. Okay, I'm done with the calculator. Alpha is 1%, guys. You agree this is bigger than 1%. Again, this sign means bigger, more than. When the sign includes a number, that means it's larger. And then, guys, we fail what? To reject HO. And the conclusion, there is not enough evidence at the 0.01 level of significance to support the claim that the mean is more than 10.7 ounces. That concludes the question, guys. Any questions? Consumer group is testing camp stoves. No, I don't recall we did that. To test the heating capacity of a stove, they measure the time required to bring 2 quarts of water from 50 degrees Fahrenheit to boiling at sea level. 2 competing models are under consideration. 40 stoves of each model were tested. So N1 is 40 and N2 is 40, guys. And the following results were obtained. You guys, this is clear. He gives you S1 and S2. You know it's a 2-sample t-test. It can't be a 2-sample z-test because he gives you S1 and S2. Is there any difference between the performance of these 2 models? And use 5%. It shouldn't be hard, guys, to figure out that here, that your null and the alternative hypotheses are going to be like this. Mu1 equals mu2, mu1 not equal to mu2, and this is where your claim is. Okay. let's assume, guys, that the population variances are not equal here. It didn't say it, but I will say that. I will make sure it is clear for you. By default, as I told you, if it doesn't say, you assume pooled is no. So it's going to be a 2-sample t-test, guys. Let's do it. And then I'll show you the paper in a second. And let me just go to the calculator. Turn it on. Okay. Stat, tests, 2-sample t-test. X1 bar, it's 11.2. S1, 2.4. I'm just reading what he gave me. N1, he says 40 from each. X2 bar, guys, is 10.1. S2, 3.2. N2 is 40. And then we're testing that mu1 not equal to mu2. And as I told you, population variances are not equal, so pooled is no. And then hit calculate. T is 1.739, and the p-value is 0.0862. Let me write them down. And alpha, let's see what alpha is in this exercise. 5%. Okay, guys. So what is p-value? Is it bigger than alpha or smaller than alpha? 5%, guys, you can write it as 0.05. And again, compare. 0 is 0. 0.0, I have a 0.0. Then I have an 8, and then I have a 5. Well, the 8 is bigger than the 5, so it's bigger. So you fail to reject HO. And then if you fail, guys, you have to start with this language. So when you select the correct answer, you select something that has not in it enough evidence at the 5% level of significance. Now, guys, if you ask me, how do I know support or reject? If the claim is in HA, you have to look for the word support here. To support the claim that, okay, what does it say in here? That there is a difference between the performance of these two models. We cannot support that there is a difference. So probably there is not a difference, that there is a difference between the two modules. Any questions, guys? Again, if you're not keeping up with me writing, you don't have to write it down. I'll PDF the file and send it to you today. Well, actually, we can do it right after I finish, because I don't need to render the video. Okay. Next question. Let's see. 11. A large company. We haven't done 11 yet, so let's do it. A large company has been hiring graduates from 2 secretarial schools. The company personnel manager gave a word processing and office skills test to all the applicants for secretarial position. The test has a maximum score of 90 points. A random sample of 29 applicants from the first school had a sample mean score of 68 points with a standard deviation of 16. An independent random sample of 25 applicants from the second school has a mean score of 71 with a standard deviation of 12. At the 5% level of significance, can we say that there is a statistically significant difference between the mean score of all applicants from the 2 schools? So that's clear, guys. what the null and the alternative hypotheses are going to be. He says significant difference. So we really need to test that there is a difference here. So let's do this. 11, school 1, school 2, and let me record some information here. N1, X1 bar S1, N2, X2 bar S2. It will help you a lot when you organize it like that, so it will be very easy to enter into the calculator. So a random sample of 29 applicants from the first school had a mean score of 68 and standard deviation of 16 points. 25 from school 2 had a mean score of 71 and standard deviation of 12. Alpha equals 0.05. And we're going to assume that population variances are not equal, guys. So pooled here is a no. Again, you don't have to guess it. By default, it is a no, but I will mention that for sure. So it's a 2-sample t-test. Okay, let's run it together. Stat, tests. And it's gonna be a 2-sample t-test. Number 4, guys. That's a most popular test between chapter 7 and 8. X1 bar. X1 bar 68. S1 is 16. N1 is 29. Then X2 bar is 71. S2 is 12. N2 is 25. Okay, that's all I need from, we're testing that mu1 is not equal to mu2. Pooled is no. And then, guys, you hit calculate. You want to do a draw, you can do that. So T is negative 0.785 and p-value is big, 0.435806. Let me show you what would happen if you did a draw. Watch. You're gonna see a shaded area on the 2 sides. Big shaded area. Once you see too much shading, that means you fail to reject the null hypothesis. See here? So the test statistic T is negative 0.786 and the p-value is 0.4358. And I don't even need to look at alpha because this is so big, it's gonna be bigger than alpha no matter what. Alpha cannot exceed 10%, so there you go. So the decision is fail to reject the null hypothesis. And the conclusion, guys, there is not enough evidence at the 0.10 level of significance to support the claim. And if they ask you what the claim is when you're doing an exercise, it's whatever it says. Here, it's right here. Can we say that there is statistically significant difference between the mean scores of all applicants? So to support the claim that there is a difference between the mean score of all applicants from the 2 schools. That concludes chapter question 11, guys. If you have any questions, please ask me. Number 12. A study was conducted to determine if the salaries of elementary school teachers from two neighboring districts were equal. I know, guys, you might put mu1 equals mu2 as a claim, but wait until you see if this is the question. A sample of 15 teachers from each district was randomly selected. The mean from the first district was 29,900 with a standard deviation 2,300. The mean from the second district was 30,300 with a standard deviation of 2,100. Test the claim that the salaries from both districts are equal. So then in this case, you're right. He's asking us to check if they are equal. So let me just write down the details here. Question 12. So you guys agree with me that HO should be mu1 equals mu2. HA mu1 is not equal to mu2, and he wants to check if they are equal. Then the claim is in HO this time. And if we get the details, guys, we do two districts here. District 1, District 2. He says 15 teachers from each school. So N1 is 15 and N2 is 15. He gives you X1 bar, he gives you S1, he gives you X2 bar, and he gives you S2, and then he gives you alpha. That's all I need. So 28,900 and 2,300. And then for the second school, second district, 30,300 and 2,100. And alpha is 5%. Again, assume population variances are not equal here, guys. So pooled is no. All right, so it's a two-sample t-test. Let's do it. Run your calculator with me, guys. So go turn it on, go to stat, tests, two-sample t-test, number 4. It's not data, X1 bar. X1 bar, guys, is 28,900. S1 is 2,300. N1 is 15. X2 bar is 30,300. S2 2,100. N2 is 15. And we need to check the alternative, which is not equal to. Pooled, we say no, and then calculate. Any questions so far? So T, guys, is negative 1.741. P-value is 0.0928. Okay. And alpha is 5%. So you guys agree with me that this is bigger than alpha. And conclusion, we failed to reject HO. Okay, I want the students to tell me what would be the conclusion now. You can text it. There is not enough evidence at the 5% level of significance to what, guys? Remember, the claim is in HO and we could not reject HO. So let me see what students are saying. To reject, I agree. You're just saying you cannot reject the claim. There is not enough evidence to reject the claim. To reject the claim that mean salaries are equal in the two districts. So probably they are equal. We cannot say that they're not. That is question number 12, guys. Okay, so question 13, where the samples are dependent. A researcher conducted an experiment to see if specific eye exercise can improve peripheral vision. A random sample of 5 people were rated for peripheral vision on a scale from 1 to 20, where 9 is considered average, and higher scores indicate better vision. Then they followed the prescribed eye exercise program and were rated again. So the vision for 5 individuals was checked before they do the exercise and then checked again after they did the exercise to see if the exercise will improve vision. So remember, improve vision is what we're looking for. Tests claim that the eye exercises improve peripheral vision using alpha equal 0.05. Okay, I want to do the difference first, guys, and then I'll ask you the big question. Difference. 9 minus 10 is what? -1. 8 minus 9 is -1. 7 minus 11 is negative what? 4. 10 minus 12 is -2. And 6 minus 9 is -3. We need to test the difference against 0, guys. And here's how you test the difference. If this exercise improve vision, that means the numbers after gonna be bigger than the numbers before, because when you improve your vision, you're gonna get a better score. So you guys, here's how you figure out you need whether you're testing a greater than 0 or less than 0 or equal 0. You just write mean of the difference, and 0, put 0 here, it's all against 0. So if this exercise works, here's how I think about it if I were you. Let's say my vision score before the exercise was 11. Assume that it works, then your score is gonna be better than 11 the next time. So let's say 13. Subtract 11 minus 13, what do you get? A positive number or a negative number? If you get a negative number, guys, that means you need to test that it's less than 0. And I think, look at the hint for you. See what the answers are. They are all what? Negative. So probably you need to test less than 0. And it turns out to be the case here. Some students ask me when they did the homework, the system was asking them to find D-bar and find the standard deviation before they do the test statistic. I'm gonna show you how to do all of this. First of all, guys, I'd like you to put all of this in L1, the difference in L1. So let's do that. Let's do it together. So stat, edit. I'm gonna clear L1. I'm gonna clear L2 so I don't confuse you with this. Okay, I'll go to L1. So I got, just have it visible for you, -1, I'll put in first. -1, -4, -2, -3. It's obvious that we need to test that mu d less than 0. You can see all the differences are negative. Okay, guys, so that's what I have. Now, some students asked me the other time, the system does not tell us to find the test statistic as the next step after we put the null. It asks us to find D-bar. And then it asks us to find the standard deviation. Well, here's how you do it. If you remember from chapter 2, guys, you can go stat, calc, one variable statistics. You don't need to do any work by hand, guys. And the frequency list should be nothing here. So list L1 and watch. This is D-bar, the first value, which is X bar. Why does he call it D-bar? Because we call the mean of the difference D. So it's D-bar, -2.2. And S, not sigma, guys. You can see on the calculator S, that's your S, that's 1. They call it S sub D. So if I want to write D bar here, guys, just for your information, it will be negative 2.2, and SD will be 1.30. Then next, he'll ask you to compute the test statistic. Well, you can use the calculator now to find it. You don't have to do it by hand. Okay, so let's perform the test. Stat, tests, t-test. Remember, section 8.3 turns out to be a t-test, guys. Enter. Okay, we're doing data. My data is in L1, testing against 0. Remember, in section 8.3, you are testing against 0 always. My list is L1, don't change the frequency, and we're testing that the mean is less than 0. Calculate. T is negative 3.773. And p-value, guys, is 0.0098. And you can see, look, X bar, you can see S. X bar is D bar. It's called D bar in section 8.3 because he uses the variable D. And SX is called S sub D because he uses the variable D again. So let me write it down. I'm going to do it on the same sheet of paper. I have room here. All right. And alpha is 5%, guys. You agree with me that this is less than alpha? So the decision is to reject HO. And what's the conclusion, guys? If we reject HO and the claim is in HA, that means we support the claim. There is enough evidence. At the 0.05 level of significance to support the claim, I'm going to copy it and paste it from here, that I exercise improves peripheral vision. It does improve vision. And that was obvious, guys. You can see all of those people improved their vision. That's went from 9 to 10, up by 1, up by 1, up by 4, up by 2, up by 3. So it looks like it works, and we were able to prove that it does work. Number 15. A random sample of 10 college freshmen takes a mathematics aptitude test before and after undergoing an intensive training course designed to improve such scores. Then the scores of each student are paired as shown in the table below. Test the claim that the aptitude test is effective in improving the students' test scores. Okay, before we do that, we're gonna do the difference, guys, together. 60 minus 70 is negative 10. 73 minus 80 is negative 7. 42 minus 40 is 2. 88 minus 94 is negative 6. 66 minus 79 is negative 13. 77 minus 86 is negative 9. You can have a hint now already what we're gonna test. Negative 3, 63 minus 71 is negative 8. 55 minus 70 is negative 15. And 96 minus negative 97 is negative 1. Again, guys, how do you figure this out? Look what you do. You say, if the test is gonna improve my score, that means if I get 50 first time, next time I'm gonna get 60. I'm gonna get a better score. and subtract 50 minus 60. If you get a positive answer, you test it's positive. If you get negative answer, you test it's negative. What is it gonna be, guys? And the other hint that you can see is what the signs that you're seeing here. So we're testing that mu d is less than 0. I know every time you see a word increase, guys, you go against it when you do dependent sample, so you do less than 0. So here, guys, HO, HA, we're gonna need to test that the mean is less than 0. And here mu d is greater or equal to 0. I'll write it down again. But first of all, we're gonna go to the calculator and input the data in there. So let's do that. So I input the differences in L1, and now we're gonna run the stat test, t-test. Section 8.3 is a t-test, guys. Data, I have data now. We're testing against 0, that's good. I put the data in L1. Frequency is 1, and then test that it is less than 0. Calculate. And that's what I got. So let me write them down. I got negative 4.217 for t, and the p-value is so small, as you can see, guys, 0.0011. So question 15. Let me write HO, HA, we just did them already. Less than 0, that's the claim. And t-test. T is negative 4.217, guys. And p-value is 0.0011. And definitely this is less than alpha. No matter what alpha is, it's going to be less. Reject HO. And support the claim. There is enough evidence at, let's pick alpha now, at the 0.05 level of significance to support the claim that the aptitude test is effective in improving the student test scores. Just copy it and paste it. Of significance to support the claim that the aptitude test is effective in improving test scores. Any questions about number 15, guys? '17. Dental Association recommend that the time lapses between routine dental checkups should average 6 months. A random sample of 36 patients records that one dental clinic records at one dental clinic showed the average time between routine checkups is to be 7.2 months. So this is X bar. This is N. With a known population standard deviation of 2 months. So guys, understand this is not S, this is sigma. Do the sample data indicate that patient wait longer than recommended between dental checkups? Use a 1% significance level. Okay, who's gonna help us and tell me what do I put here? This is from section 7.2. What are we testing? We're testing against 6 months. What would be the null and the alternative? He says, do the sample data indicate that patient wait longer than recommended? The recommended time is 6 months. So would you guys agree with me that we need to test that the mean is more than what? 6 months. So people are waiting longer than 6 months to do the cleanup. Okay, I have N, guys. Let me just get it. 36. I got X bar to be 7.2 months. And I got sigma, not S, 2 months. And I got alpha to be 1%. All right. So this one, guys, will be step. You go to tests. It's a Z test because sigma is known. Z test. Stats and enter the values. U0, guys, we're testing against 6 months. Sigma is 2 months. X bar was 7.2, I believe. N is 36 patients. And we're testing that it is greater than. There you go. And then hit calculate. This is a right tail test, guys. So Z is 3.6, and let me write down the p-value because some of you still made the mistake on the assignment with the p-value. So this is what I got. I'm just gonna copy it and paste it and then explain how to interpret that because some students still did not interpret that right. You guys, when you see something like that, please do not ignore this. Because I know some students, what they did, they just put, this is the p-value. With the p-value, it's impossible to be more than 1, so it can't be more than 1. So the E minus 4, guys, means that you have to move this decimal place 4 digits to the left. So actually the p-value is this. You guys can assume when you see the E minus 4 or minus 5 or minus 6, whatever, that the p-value is almost 0. You will be safe, you know, to make this assumption and make it less than alpha. So reject HO. And what is the conclusion here? There is enough evidence at the 1% level of significance to support the claim that, just copy it and paste it from the problem, that patients wait longer than recommended between dental checkups. Okay, so that's, I think that was the last question that we did not do in the review. That will complete the review.